In the quantum world, particles are produced all the time and they disappear all the time. These are called virtual particles. They come out and then they disappear again. So that's what's shown in the little loops. You know, they're just appearing and then disappearing all the time. But if this happens near the event horizon of a black hole, the kind of picture is that one particle can go into the black hole and then it's prevented from kind of joining up and disappearing with its partner, and the other partner goes out and it just escapes. Right? So that's how the Hawking radiation is produced. You know, kind of crazy quantum physics that means that something can just randomly, once in a while, jump out of a black hole. That's another way of thinking of it. I find it quite hard to do a graphic to sort of show that, right? So the basic idea is that there's no sharp event horizon, but basically just around that region, there's all kinds of quantum stuff. And if something falls in, you keep track of the quantum stuff. The surface is quantum and it's captured by quantum excitations. The information is being stored in a giant hard drive at the surface. Okay, this is the basic idea. And for the purposes of this evening's discussion, the details of how we do it don't really matter so much. So there's like almost a giant hard drive. And moreover, it's a bit of a weird quantum hard drive too, because it's storing information as qubits. So we now made the connection with quantum computers. So these are really fantastic storage devices. In the traditional picture of falling into the black hole, our poor, brave astronaut falls into the black hole, they fall through the accretion disk, they may notice some strange distortions like this, weird Doppler shifts, but they keep falling. In the newer version, the quantum perspective, which is consistent with Hawking's picture of Hawking radiation, is that as you fall in, information gets captured and stored. So our poor astronaut is effectively being pulled into quantum information. Quantum forces are pulling them into pieces, basically ripping them into individual little quantum bits. Right, that's the idea. It's a quite a sort of striking sort of visualization here. So there's really nowadays an interface between the quantum computing and the black hole theory communities in terms of thinking about these things.